Okay. All right, here it is. So that something's happening, right? So something is wrong in terms of the construction productivity. And also, if you check this number, the productivity of construction industry still decreases about 0.6% per year. We are not improving at all. So that's the number one problem. And once again, guys, I'm just showing you all the evidence. I'm just showing you all the observations, but I'm not giving you my explanation. I want you guys to think about the story behind. Issue 2, overruns. This chart shows a survey on almost 2,000 projects, and this one shows a time overruns in days. So this is the days, this is the number of contracts. So this one shows the likelihood. We are supposed to be where? 0, right? That means finish the project on time. So this is the 0 line. What do you see here? The majority of the projects are overrunning their schedule. This one shows time, shows cost. Based on 258 projects, same thing. We're supposed to be here, but the majority of them, what happened? Overrun their budget. Overrun becomes so prevailing, it becomes a must in the construction industry. So that's why when people prepare the budget of a project, they always add what? Contingency, right? They always add a 15%, 20% contingency. And the same thing to the schedule. Since the day one, project manager knows, oh, my project is going to overrun both time and the budget. The question is how much? That's interesting. Think about that. You are the project manager, you are the estimator, you are the scheduler. You're supposed to give me the right number in terms of cost and time. Why you're telling me, yes, we'll be overrunning numbers? This is not normal, right? But we're considering that as the normal. This is failure. This is based on the Bureau of Labor Statistics. So it shows the survival rate of construction companies. This is the years in business. This one shows the likelihood that they are still surviving. It means what? It means if you're starting a new construction company today, in about 6 years, I give you a phone call, there's only 30% of chance that you are still running the company. 70% of the construction companies would die after only 6 years. Is this normal, guys? No, this is not normal. But everybody is considering this as normal. That's something that is really bothering me. Like, we are seeing all the issues, but why everybody is considering, oh, this is normal, this is construction. Issue 4, claims. Once again, this is based on literature. 52% of construction projects will end up with at least one claim of some type. What is the last phase of a construction project? Lawsuit. So is that normal? No, it's not normal. Profitability. All right, this is the magic. When a company tells you, hey, you know what? I'm so proud of my company. My annual revenue is $10 million. No, leave that guy immediately. So this one shows for different market sector, the profit rate. Heavy civil, 0.83%. Residential, 0.78%. Industrial, 0.88%. Material supplier, 1.25%. Average sector, this is the number from 2010. So it was affected by the 2008, depression. The number was better in 2007, right before, but only about 5%. Let me remove that, sorry. So the largest 4 commercial builders in 2010 was only about, the average profit rate was only about 5.7%. Daycare, 10.43%. I don't know how they calculate this profit margin for daycare. I don't know. I really don't know. But this is based on the Bureau of Labor Statistics. I guess it's based on their average salary and the time they got to pay. They do the magic. But think about that. Daycare can earn much more, okay, than construction. And this one shows the companies, Floor, KBR, Skanska. That's all really big construction companies. You guys recognize the names, right? That's only about 2%, 3%. Google, 25%. Apple, 36%. Now think about that. Now, why we are having all the issues in the construction industry. Unstable production rate. Unlike manufacturing, so if I ask you, hey, this is the production line and you are building this foam, and so tell me how long it would take you to build this 1,000 foams. So you observe the production line for a while, and you can definitely give me a number. Make sense? Unfortunately, that wouldn't happen in construction. This one shows the production rate for underground piping, how to bury the pipes underground. This is the hour per linear foot, like per linear foot, how long it will take. This is the distribution from 0.33 to 2.3. This is what? This is like 7 times, 8 times longer, than this project. How would you predict the duration of a project? But where's the problem? Why we are seeing this so volatile production rate? This is an example to erect the critical pipes from 2.12 to 14.36. Once again, about 7. The slowest project is about 7 times longer than the fastest project. Why? I don't know, but there's a problem. Safety, and not surprising, construction is still among one of the most dangerous jobs in the US and also all around the world. And whenever there's a recession, construction is always the most affected one and the slowest to recover. Guys, we are experiencing another recession now. The COVID-19 has significantly affected the construction, even though we don't see that now, because we still have a lot of contracts that we have to finish. But I guarantee you, next year, you will see a significant decrease in construction market because the owners wouldn't have funds to support the new projects because nobody wants to buy new homes, right? So if you check the unemployment rate, this is construction. So after 2008, our unemployment rate actually hiked all the way to 22%. That's in the construction industry. And the recovery was the slowest among all the industry. What's so interesting is 2008, who created the 2008 recession? The financial industry, right? See what happened to them. Their maximum unemployment rate was only 7% and recovered so fast. So that's really pathetic, right? Well, also aging industry. This one shows the really senior people and really young people here. But what we see here, we see the blue one and the orange one are supposed to be the mainstream of construction professionals from year 20 to 45. But if you check the size, from 1985 to 2010, we see this range is decreasing. So we do have a shortage of strong laborers. Lazy innovation, that's what I call lazy innovation. This is innovation produced by industry. I had the answers. Can any of you tell me this green one that represent about 70% innovation, that's which industry? Can anyone tell me that?
Manufacturing.
Manufacturing? Let me check. Yes, that's correct. Construction here, about 9% of the new patents. Academia is here. Europe represented about 55% of the new inventions, like new patents. America is here. Asia is there. All right. And this is a prediction. This is a survey in 2007. I don't have the number, but in 2007, it was predicted that Asia will become the engine of innovation. So in year 2020, if you count all the patents generated all across the world, about 52% would be generated in Asia. And America would be still only about 10% of that. All right, so guys, think about the problems we just talked about. decreasing productivity. We used to be a better industry than manufacturing industry compared in terms of productivity. We are experiencing significant overruns, significant business risk, a lot of lawsuits and claims, very low profit margin, very unstable production rate, unpredictable production rate, very unsafe, can be easily affected by the economy and very difficult to recover. And no young man wants to go to the industry, and there's no innovation. Where's the problem? So like I mentioned, it must be some systematic problem. And personally, I have a lot of answers, I have to say. Now think about how the new technologies would improve everything, okay? How technology can be used as a solution to that. So before I talk about this, I think it's boring to just talk about data information and all the basics. So I think I'm going to adjust the sequence of my class. So I will skip all the way to this thing. Industry 4.0 and a separate physical system. Why? I think we are facing a historical opportunity today to solve all the problems we are facing in the construction industry for more than a century. And this is the Industry 4.0. And when we talk about Industry 4.0, what that is, the major thing is called cyber physical system. So what is cyber physical system? I'm going to play this video quickly.
Your next refrigerator may know more about your diet than your doctors.
Can you hear the sound of this video? Okay.
How many objects do you have that are connected to the internet? About a decade ago, you probably would have said one or maybe two if you were an early adopter of smartphone technology. But today, oh, well, I've got a work computer, I've got a personal computer, I've got a tablet, I've got a smartphone, I've got a video game console, I've got a media player, I've got a smart TV, I even have a smart refrigerator. Now, extend this trend outward, and what do we get? Well, it's estimated by 2020, there will be 50 billion objects connected to the internet. Now, that's billion with a B. It's also estimated by the US Census Bureau that there will be 7.6 billion people alive at that time. So that means that for every person, there will be 6.6 objects connected to the internet. We're talking about a world blanketed with billions of sensors. These sensors are taking information from real physical objects that are in the world and uploading it to the internet. It's a world where your environment transforms as you walk through it, because technology that you may not even be aware of is monitoring your every move. It's a world that's constantly changing all around us due to these sensors and the internet, and we call it the Internet of Things. Let's stroll into the living room of the future. Now, immediately, this room identifies you and taps into a cloud-based profile of preferences like climate control, music, lighting, and decor. Had a long day at work? The room knows, based on the calendar app on your phone and biosensors that detect the stress via blood pressure and heart rate. So it turns off the rockabilly surf guitar you usually listen to and switches to a more soothing classical music. From environmental sensors outside and maybe even worn within your clothing itself, it knows it was snowing earlier. So the climate control begins to crank up the heat in anticipation as you walk through the door. Now, on the software side, we're talking about algorithms that are so sophisticated, they may be able to predict what you want before you know you even wanted it. So when you walk to the refrigerator, it tells you not only what's in there, it tells you what you can make with the stuff you already have. And it's already telling you what's inside and what's the perfect meal based upon your mood, your activity level, and maybe even, well, your weight loss plan for some of us. As for how many objects could be connected to the internet, well, consider this. The latest version of Internet Protocol, IPv6, creates more potential addresses than there are atoms on the surface of the Earth. So we're going to live in a world completely filled with sensors, with data, reacting to us, changing every moment dependent upon our needs. I'm no longer going to be asking you, hey, what's your favorite color? What's your favorite music? I'm going to ask you, what's your reality like? I know what mine is when I walk into my house, how the world reacts to me, but how does it react to you? This is more than philosophy. It's more than technology. It is altering reality as we know it. And it's all regulated by the Internet of Things.
How many of you have heard about the term Internet of Things?
I have.
You have. So why this is important? You know, Internet of Things are several physical systems. I'm going to talk about. They're actually presenting the same thing. It's actually the landmarks, the hallmarks for Industry 4.0. We have experienced so far 4 major industrial revolutions, and each revolution actually changed the entire human society. Industry 1.0, that's about what? Steam engine. Industry 2.0, that's about mass production, especially the Ford T-model cars. Industry 3.0, that's about automation, robots, computers, and electronics. And Industry 4.0, that's about several physical system, Internet of Things, intelligent machine. I'm going to show you why each industry revolution was so important to human society. So Industry 1.0 was the first industrial revolution, happened in about 1760 to about 1840. So that's actually almost a 80-year revolution. So this transition included going from hand production to machines. And we're talking about using, capture the chemical energy from, the steam engine and to increase, the labor productivity. So the hallmark of this Industry 1.0 is actually steam engine, right? It started in UK in the textile industry. And this is a wall steam engine. And I think everybody learned this, right, in high school. Why this is so important. This is the first industry revolution. So Industry 2.0, or the second industrial revolution, we call this a technological revolution. The first one we call the steam engine revolution. So it happened right after the first revolution in the period of 1870 to 1914. And as you can see, each industrial revolution, the pace will become faster and faster. So the duration would take shorter. So this one shows the advancements in manufacturing and production technologies enabled the widespread adoption of systems such as telegraph, railroad networks, gas and water supplies, and the sewer system. And we have this electrification. We start to use what? Electricity. So around that time, the US started to use the street lights. So everybody started to use the light bulbs. And right after 1914, Americans started to use air conditioning. So that's actually happened about 100 years ago, the second one. And the hallmark of that is the mass production. What is a mass production? This is this is a brilliant design of a new way to produce things. Can anybody tell me something about what is mass production?
Produce like different items in one time, maybe.
So what's that?
So like generate like different items at one time.
Okay.
Maybe.
Yeah, I think that's part of that. What else? So why this mass production is different?
You have workers repeating one task and passing it down onto the next person instead of having one or two or
Exactly.
a small group of people working up the whole chain.
Exactly. So let me try to see if we can find some graphs here, like images. So before mass production, how do we produce car? Let me see if I can find some good picture like this one. Can you guys see this picture here? Oh, come on, I need it to be bigger. Okay, anyway, so before the mass production, we basically had workers surrounding a car and assembling the car. Make sense? That was a very natural way to build things. Think about it. Hey guys, I want you guys to build something for me for this class. What is your first reaction? Let's build something. Let's find a room, and then you guys be surrounding that. Yeah, that was the original way of producing things. And this guy, Ford, the founder of the Ford auto manufacturer, he basically thought about this method. Hey, why don't we build this assembly line that is sending the components automatically, and you are just standing in front of something, you're repeating your actions every day. So think about that. What's the benefits of doing this? Muscle memory, right? So once you repeat doing that, you don't use your brain, you just use your muscle. So the productivity increase, right? So, and also I can easily control the arrows, I can easily control the production process. This is amazing invention for the second industrial revolution. And because of that, the T model is a great success. If you guys are interested, you can check the documentary. Like, are you guys using iPhone? When iPhone was popular around 2010, when the ringtone starts, everybody started to get the phone, right? Because everybody was using iPhone. There was a moment in history, everybody was driving the same car, same color, same type, all Ford T model. That's how successful it was in history. That's the second. The third industry, that was after the World War II, called the digital revolution. It's actually, we're still in the process of the third revolution. So it was a huge leap ahead, wherein, we invented a computer and automation and robotics. So we're replacing a lot of labor works with automation technology. So if we have to use the keyword to describe the third industrial revolution, that's automation, all right? So robotics and automation technology, modeling and simulation, human as the commander, and we have the isolated equipment to do a lot of things for us. All right, why industrial revolutions are important? I found this graph showing the GDP of different countries from the 1700 to 2025. This blue color is the US. This orange color is UK. And we also have other countries. This is the first industrial revolution. And remember, the first industrial revolution happened in which country? In UK, right? So what happened after the first industrial revolution? Check the orange curve. Basically, originally the UK was comparable with US, but then after the first industry, they took the leadership in the first industrial revolution, and see their GDP just basically increased dramatically, right? Second industrial revolution happening in which country? In the US, and see what happened. And that's a very interesting curve. Right after the second industry, this is the US GDP. Third, that's also happened in the US, but spread to the world very fast. So we start to see right among the third industrial revolution, we see the GDP in India, in China, in different areas of the world start to hike. So that's why industrial revolution are so important to a nation's economy. You guys probably have heard a lot of stories about the tension happening in 5G, right? I don't want to talk about the politics behind the story, but the one thing that people are fighting that is definitely about the leadership of the next revolution, okay? Which is Industry 4.0. So we officially have this term in 2011 when there was a world leader convention, and I forgot who mentioned that. I think it's the German's Premier Minister. She mentioned this word, Industry 4.0. So Germany was trying to take the leadership in Industry 4.0. So Industry 4.0 describes the trend towards automation and data exchange in manufacturing technologies and processes which include cyber physical system, the Internet of Things, cloud computing, cognitive computing, and artificial intelligence. All right, quick question. What is the difference between Industry 3.0 and the Industrial Revolution 4.0? They all look like robots. They all look like automation, but what is the biggest difference? Can anybody let me know?
Maybe robots are more smart in this kind of revolution.
Use of artificial intelligence.
So artificial intelligence, yes, that's definitely the difference, but it's not the biggest difference between the two revolutions.
Less manpower, yeah.
Once again, it's part of that, but not everything. Not the biggest one. Let me show you the keyword is connection. Industry 3.0, everything, even the machine is smart. They work in isolated way. But 4.0 features in connecting. That's why we call it Internet of Things. Internet of Things is about what? Connecting everything with each other. So the sensors from your thermostat will send the data to your AC terminal, and your biosensors will send the data to that video player, and so they are exchanging data. They are forming a huge network of data exchange. That is the main feature of Industry 4.0, and that's why 5G is important. Now you understand why 5G is important, right? Because 5G is the infrastructure for data exchange. That's Industry 4.0. So this is what is cyber physical system. This is cyber physical system. We have the physical system, which is the real world we are seeing now, the natural or human-made systems like roads, bridges, even the natural thing like rivers, governed by the laws of physics. Of course, we are in the physical world. The cyber system is actually not just software, not just computing, but it's actually a model of the real world. All the algorithms that calculate that. For example, if you want to optimize the traffic flow, then the algorithms how to optimize the topology of the traffic network will be the cyber system. And the actual traffic network will be the physical system, right? Cyber physical system is actually closed loop. We are talking about to send huge amount of data from the physical systems to the cyber systems in real time. And we are doing the computing really fast on the fly and generate the optimal solution and send it back to the physical world to change or intervene the process. This loop happens every single second, form a continuous loop. And this entire system is called a cyber physical system. Let me give you an example, smart traffic. You guys know that sometimes when you're driving, there's no car waiting, but the red light just stays there forever, right? Why? Because it's not cyber physical system. What does cyber physical system look like? They should have sensors to sense how many cars are here, and also can exchange data from all the other main roads and the intersections and make a prediction. Oh, I think there won't be too many cars waiting in this intersect. They send the sensor data to this cyber algorithm, and the cyber algorithm will basically do some network science and mathematics, say, okay, I'm going to reduce the traffic light duration by 50% here, but increase the right traffic light duration by 25% there. So I can optimize the traffic flow, right? And then they send the decision back to the traffic light. And they keep doing that. That's called a cyber physical system. Make sense, guys? And Internet of Things is about the connected sensor network. So we're not just using the cameras. We're also using, let's see, temperature sensors, satellite, the cell phones of the drivers, and also the cars are connected. Some infrastructure monitoring sensors. We're using a lot of sensors. That's called Internet of Things. It's actually Internet connected sensors. And the cyber physical system, the cyber system, we call it digital twins. It's a digital replica of the real world, simulating the process and the behavior of the real world, generate the optimal solution for the real world. And this loop is called a cyber physical system. Make sense? Definition. So cyber physical systems are engineered systems that are built from and depend upon and the seamless integration of computing and physical components. Information processing and the physical process are so tightly integrated that it is not possible to identify whether behaviors are the result of computations, physical laws, or both working together. That's CPS. CPS are transforming the way people interact with engineered systems, just as the internet has transformed the way people interact with information. Make sense? So CPS is actually the new internet that we can influence the real world. Smart CPS drive innovation and computation in a range of application domains, including agriculture, aeronautics, building design, civil infrastructure, energy, environmental quality, healthcare, personalized medicine, manufacturing, and transportation. It's everywhere now. Advances in CPS will enable capabilities, adaptabilities, scalability, resiliency, safety, security, and usability that will expand the horizon of these critical systems. And talking about the components of that, like I mentioned, CPS actually cares about the physical world sensing and also the computation of that, but of course, the communication part of that. So there are 5 components of that: sensor network, and actuator. This is about collecting information from the real world. This is about changing the real world. So these 2 are the physical part of CPS. And we need a communication network to exchange data. We need a computing server to do all the algorithms and all the optimization. And we also need the storage to save the big data. All the 3 components here are about the server. So sensor, communication, actuator, storage, and computing. That's the 5 components of CPS. So let me skip this part and play an interesting video. This one was a TEDx talk I was giving 2 years ago about how Internet of Things can change the future of civil engineering. So I hope you guys enjoy this talk. Let me see how I can better share this video. So let's see, share. Is there any way to share just video, guys? Okay, anyway, let me still share this one.
Howdy. How many of you like Japanese cartoons? So we do have a few in the room. Okay, great. So when I was a kid, I really enjoyed watching Japanese cartoons, especially this one called Doraemon. So Doraemon is a robot cat from the 22nd century. So he time traveled all the way from the future to the present time, brought all the future technologies to help children today. I remember there was one episode talking about technology called computer pews. So this kid just attached the computer pews to everything in his room, like the TV, the fridge, even the books. But all of a sudden, these things became smart. They could talk to each other. They could follow his instruction. So it's an amazing story, right? The end of the story was a totally tragedy zone. First, it was the coffee machine. So the coffee machine was not feeling happy because the kid was assigning too many things for them to do. Then he shared his feeling with his best friend, the TV, the fridge, and a baseball bat. They had a meeting and they decided to start a rebel movement, to fight for their human rights. So this cartoon was made in the 1960s. At that time, the authors thought, oh, this computer pew technology wouldn't be realized until the 22nd century. But only after about 60 years, we have it now. We just gave it a different name, Internet of Things. Internet of Things is a kind of technology that connects all the devices and the things surrounding us, let them exchange information so they can make better decisions for us. According to a survey, by 2020, more than 50 billion devices and things will be connected, forming a huge network of things that will fundamentally change the way we live and work. It's a beautiful dream. But there's just a very tiny problem like office, money. Most of us are still using the old technology appliances, right? So in order to make IoT possible, we have to upgrade them to IoT compatible. And according to a recent research, the average cost for you to upgrade everything in your home can be as high as $30,000 per household, and that's only the cost for hardware. So it's a really large bill. Nobody would like to pay for that. And that's obviously an obstacle in the way towards IoT. So what else can we do? How can we reduce the cost? How can we talk to the things surrounding us in a different way? And my answer is vibration. You know, everything in our world is vibrating. We just cannot see that. The podium, the chairs, yourself, and even this building, they are vibrating. So things surrounding us are trying so hard to talk to us, and the language they're using is vibration. So that makes me to think, if we can somehow translate their vibration into English, then we can make IoT much cheaper, right? So I would like to share 3 IoT projects I'm currently working on: construction tracking, driving safety, and bridge inspection, all engineering applications. The 2 big questions I would like to ask are, first, what are the things trying so hard to talk to us, to tell us what's going on? And the second, how can we understand them? Story 1, construction. You probably don't know, construction is a very important part of our economy, representing about 10% of GDP and 10% of employment. But on the other hand, construction is also one of the most dangerous careers in the world. It is super labor intensive. For a big project, you are expecting more than 1,000 construction workers working at the same time. And because of the complexity and the uniqueness of construction projects, it can be difficult to track what's going on the job site. Like this project on the screen, we cannot deploy cameras to track the construction activities. So at present, we usually just heavily rely on the manual reporting of construction workers. That creates some huge problems about productivity assessment and, more importantly, safety. So what can we do? What are the things trying so hard to tell us what's going on a construction job site? Construction tools. Small tools, such like a power drill, hammer, cutter, chainsaws, are heavily used in construction operations. For one project I was working for, there were more than 3,000 pieces of construction tools being used at the same time. So check this map yourself. And don't worry if you don't recognize the tools on the screen, because I don't know their names either. We just need to understand there are so many tools being used at the same time, forming a huge Facebook social network. And if we can understand what they are talking, then we can understand what's going on the job site. So how can we do that? Vibration. You know, different tools are vibrating in very different ways when you're using them, right? Even for the same tool, like a power drill, when you are drilling wood, concrete, and steel, the vibration patterns can be very different. So in order to identify the difference, we applied a mathematical model. Here, as you can see, X is different frequency level, from 0 Hertz to 5K Hertz, and Y is their intensity. If you check the up and down of this graph, it's kind of like a fingerprint. And then we can project the fingerprint to different construction operations. So how can we track the vibration of tools? And we debug a system. This is the sensor we're using. It's very small, but it's super powerful. It can track the 3-direction vibrations at the frequency of 5,000 data points per second. And it's super cheap, only $2. You can buy it from Amazon. And so we just attach this to different construction tools and collected a whole lot of vibrations. The last step is to plot the Facebook social network of construction tools. You know, some tools are always being used for the same operation, some don't. It's kind of like, hey, the power drill, the cutter, and the chainsaw, they are good friends. They always want to go out together. right? But that hammer, he's a weird person. Nobody wants to work with him. So if you check the social network of construction tools, and as well as their individual status, then you can somehow predict what's going on the job site with all the tool vibration. Now imagine, in the future, there will be a huge heat map in front of a product manager, so he can check, oh, what's going on in this area, what's going on in this area, oh, that construction worker is doing stupid things now, let me stop him. So vibration is the language of construction tools. The second story is about driving. Let me ask you a question. How many of you have ever driven on a bumpy road before? Great, everybody in the room. So in fact, 22% of the US roads are considered in poor condition. And the cost to fix our problem is estimated to be $170 billion US. Unfortunately, every year, more than 35,000 people die on the US road. And about 14% of the accidents can be tied to the poor road condition. So it's critical and urgent for us to inspect the road damage, right? At this point of time, we are doing that, heavily with a manual process. We send people outside, usually just once a year, ask them to visualize the damage, or we use the very expensive laser scanner to build the 3D models, but very expensive. The frequency of data collection is not satisfactory at all. So what else can we do? What's plan B? What are the things trying so hard to tell us the road condition? Your cars. So you probably have that experience. When you are driving on a bumpy road, your car tends to vibrate badly. But if this is smooth road, the driving can be really enjoyable, right? So if we can collect the vibration of the cars, then somehow we can predict the road condition. To deploy the sensors on millions of cars can be very costly. So this time we decided to use a really cutting edge and very uncommon technology, your phone. Everybody is carrying phone while driving, right? So you either throw it to the passenger side, put it in your pocket, attach it to the windshield, or are texting while driving, which is totally illegal. So please don't do that. But the phone has really powerful vibration sensor. It can sense the 3-direction vibrations, and then it also has a gyro sensor can collect the pulse of that. So the idea is to develop some free apps and send the app, shared app with millions of US drivers and ask them to share their data with us. Then we have millions of data collectors every second. So in the future, when you open the Google Map, you will see another layer called driving comfort, and it will highlight all the bumpy roads. Great. In order to test the concept, we have to do some pilot study. Unfortunately, Texas is doing such a great job maintaining its road. We couldn't even find some, enough potholes, so we were so disappointed at Texas. Luckily, we found some really bad roads on campus, so we could do some pilot study now. So we send out our vehicles, we collected the vibration, and once again, we plotted the fingerprints of the vibrations and tried to link that to different road damages. The result, the preliminary result was surprising. Now we're able to predict 4 types of road damages just based on the vibration of your vehicle. What's next? You have to remember our phones can also communicate with each other, and the vibration sensors can be used to predict if you're switching between 2 lanes or if you're accelerating. So in the future, it can be like this. Hey dude, I'm going to switch lane. And the other car say, okay, I'm going to slow down. So we can exchange the data among all the phones, and all the cars will be connected. It's a really cheap solution to the connected vehicles. So vibration is also the language of your cars. The last story is a very sad story. You probably have learned a recent incident in Florida about the bridge collapse, right? Unfortunately, it was not the first time. Just recently, 2 bridges also collapsed in California. In fact, since the year 2000, 76 bridges collapsed or closed due to structural failure. 52 people got killed, and 186 people got injured. There are more than 600,000 bridges in the US, and it's critical for us to understand their current health condition. So how can we track their health condition? What are the things trying so hard to tell us the health condition of all the bridges? The bridges themselves. You know, every bridge is vibrating, and their vibration pattern can tell a lot about their current health condition and when they would collapse. It's just the vibration is so tiny and we cannot visualize that. So working with my colleague from Arizona State University, Dr. Pingbo Tang, we are using cameras to understand the vibration bridge. We just took a video, that's a regular video, and then we amplify the vibration, the light reflection by 1,000 times. Now you can easily see the vibration of the bridge. It's the heartbeat of this bridge. Then we collect the data and send it to a computer simulation model. Now we're able to predict the health condition, the age of this bridge, and more importantly, when this bridge would collapse. So I have talked about 3 boring engineering problems. You might thinking now, so what? Will that affect my daily life? And my answer is definitely yes. I have done something at my home. I attached vibration sensors to everything in my home, the fridge, TV, and even I documented the vibration when I flush my toilet, which I didn't show it here because it's not appropriate for this event. But now my home becomes really smart because it understands what I'm doing. It understands if I want to turn on the TV, if I want to just get a beer from my fridge, okay? It is a really cheap solution. It's kind of like the computer pills. Instead of paying $30,000, I have a really cheap computer pills, just like what you saw in that cartoon. So at the end of my talk, I really want to use the last slide to show my respect to the author of the Japanese cartoon Doraemon, Fujiko Fujio. He was my personal mentor. He was the reason why I decided to do a PhD, because I really wanted to realize his dreams. For over 20 years, he envisioned and created more than 2,000 technologies. Many of these technologies have been realized today, but more are yet to come. Today, I'm still stealing his ideas when I'm writing research proposals. So next time, if you see I'm watching Japanese cartoons in my office, I'm actually doing serious research. Thank you.
All right, thank you guys. So what do you think? Does technology must be, should technology must be expensive? And I guess my investigation, my research was giving a different answer, right? So like it all depends on creativity. Like if you can see the new dimensions that a lot of people tend to ignore. Like for example, for that research, when we talk about sensors, you're probably thinking about something like using electricity or magnetic field, something that is so expensive. But think about that, vibration is a common language, like everything's vibrating. It's just using the right methods, machine learning, and using the right angle, you can definitely collect a lot of unseen and hidden information. So that's all the TEDx talk was about. All right, so that gives you a quick example of how creative we could use, CPS concept to advance the productivity and the safety of the construction. But now I want to show you this figure. This is something called the pyramid, the hierarchical structure of CPI system. Everything follows the 3 main phases: data collection, data analysis, and using the data to make decision. So this is actually the 5 levels of a CPS. If you check this figure: connection, conversion, cyber, cognition, and configuration. Connection is about deploy the sensors to collect the raw data. Conversion is about to convert the raw data into some information that we can understand, okay? Cyber is about the digital twin model that is running, all the algorithms, like machine learning is here. Cognition is about making decisions, okay? So finally, the configuration is about changing the environment. Make sense? So let me repeat. Data collection is here, sensors. Conversion is about translate data into information. Cyber is about running machine learning, running optimization to help you make a good decision. Cognition is to make a good decision, for example, to shorten the duration of the red light or make it longer. And the configuration is to make the actual change. If you're comparing, the manufacturing industry and the construction industry, what are the main differences? What are the major differences? Construction industry is highly labor intensive and the environment is changing. You are building a building, day one, day two, the entire job site will be very different because you are changing the environment. But a factory would remain the same for a year, okay? And the construction is outdoor, manufacturing is indoor. Manufacturing uses a lot of standardized workflow, but the construction, you cannot control where people are moving. You cannot control where people are doing, right? So given that, we do have unique challenges for each level of the cyber physical system. For data collection, how can we identify cheap sensors, maybe some universal sensors that can easily plug in and transfer to another user application? Because I don't want to waste my money to develop sensors for each of the construction job site. Conversion, now I collect all the data, but how can I know this data represent this activity? Because everything is different. Every project is different, right? So I collect the same vibration for this project, but maybe for the other project, it means a totally different operation. It means totally different task. And also cyber one and the cognition one, like a running optimization thing. Unfortunately, because humans are so unpredictable, even though I know what's going on my job site, it's still very difficult to optimize human behavior. Make sense? I can optimize where to put my materials, I can optimize the layout, but how can I optimize 2,000 construction workers? And finally, how can we encourage the industry, the business decision makers to adopt the changes, because it means additional cost to them. If you are talking about deploying new sensors, deploying these new computers, methods, it involves additional cost to them. Then we have to make change. We have to influence their business. We have to influence the real world physical process, but how? That's all the unique challenges that we don't see in the manufacturing industry. Think about that. It's so easy, comparably so easy for manufacturing to adopt this cyber physical system concept, but so difficult for us. That's why CPS is becoming so popular recently in the construction research area. It was a popular concept about a decade ago for manufacturing, but now it becomes so popular in our area because there are so many unknowns and so many knowledge gaps. Make sense? All right, so talking about the CPS application, I want to show you the several videos. This is the biggest CPS application, the user we know, manufacturing.
What is it that helps manufacturing companies stay ahead of the competition? The key is digitalization. With its help, we can synchronize work steps and optimize entire value chains. This turns companies into digital enterprises. But what does that really mean? It means optimizing ideation processes and planning with the support of a digital twin. Design products digitally and simulate their characteristics virtually. Plan, simulate, and engineer production facilities digitally. Evaluate and assess the performance of real production and products in real time, in order to optimize both continuously. This is only possible with a holistic approach. The Digital Enterprise Suite.
Siemens. Ingenuity for life.
Three components of, not three components, three major things, right? Sensor network that can track the status in real time, continuously. The module that can run optimization, can optimize the layout of their assembly line, the resource, and also, something, the loop, right? That it can continuously change and revise their current work plan, their location of their machine, their robots. So that's actually the CPIS use. But Siemens gives a name called the digital enterprise. Smart energy systems, we're talking about the power grids, smart power grids that can sense the consumptions in each household and run a top-down optimization algorithm to see how I should allocate, the energy, the power use. That's a smart energy system. Smart city. Let me show you this interesting video, like how CPIS is changing the view of future city. That's commercial.
Just how smart is your city? Chances are it's getting smarter by the year. Many governments around the globe are racing to infuse technology into just about every aspect of its city's operations. And I mean every part.
Including public transportation, IT connectivity, water and power supply, sanitation and solid waste management, efficient urban mobility, e-governance, and citizen participation.
And it does this using every buzzword imaginable, from big data to the Internet of Things.
So how does a smart city work? Let's look at 3 examples.
Here in Singapore, the city-state might be the gold standard of the most extensive effort to collect data on daily living.
The government is now deploying systems that can tell when people are smoking in prohibited zones or littering from high-rise housing.
Singapore launched its own Smart Nation program in 2014 and will add more cameras like these, so the government can effectively monitor crowd density, cleanliness of public spaces, and even the exact movement of every locally registered vehicle.
Much of the data it's collecting will be fed into an online platform called Virtual Singapore that gives the government access to how the city is functioning in real time. It could help the government predict how crowds might react to an explosion in a shopping mall, or how infectious disease might spread. Over in Dubai, more than 50 smart services from 22 government entities have been rolled out as part of the government's Smart Dubai initiative. Using the government-provided app Dubai Now, you can do things like pay a speeding ticket, which likely captured you on a public camera and then emailed you the ticket directly. You can also use the same app to pay your electric bill, call a taxi, track a package you sent to your friend, find the nearest ATM, renew your vehicle registration, track the visa status of a relative, and report a violation to the Dubai police. Now head over to Barcelona, where one research firm estimates the city will save billions of dollars a year in energy costs just by installing smart systems like these. Number 1, smart streetlights. Public lighting that adapts and dims when there's no activity but brightens up when sensors detect motion. The second, parking sensors. Instead of driving in circles looking for a spot to park, drivers can get real-time information on an app which locates free parking spots. Sensors on the street curb use lighting and metal detectors to know if a parking spot or loading area is occupied. And finally, garbage sensors, which are actually compact drop-off containers which have a vacuum network through pipes which sucks up trash below ground. The automated waste collection not only lowers noise pollution from garbage trucks, but also lowers costs and keeps bad odor away. Juniper Research estimates that by 2021, cities will save nearly $19 billion by making their cities smart.
But of course, to save money, sometimes you have to spend it first. The global smart city market is estimated to attract $15 billion by 2021, and that's just for software. So now companies from Microsoft to Cisco are aiming for a piece of it. In Singapore, Upton Saidi, CNBC.
Still watching? Perfect. Click here to watch a...
All right, so smart city actually is also a very popular topic right now. So I don't know if you guys are interested in like a National Science Foundation research. It basically shows the trend of the future technology. So they are funding a lot of smart city research right now. So like I said, this is also a fairly promising area. And this graph, I found it to be very useful. It talks about, so if you guys are graduate students, so I assume some of you might consider doing a PhD in the future, or maybe something about R&D, you know, research and development. So this one actually shows the area that is so promising for CPS, the research area. So for example, how we can engage a better, you know, feedback system, better sensing technology, better intelligence, how to make the decision and the data exchange more real time. Security, how do we have a resilient system that is so robust to the cyber attack, data privacy issues, and also, you know, the applications of that, like communication, consumer market, energy infrastructure, healthcare, manufacturing, military, physical security, robotics, smart buildings, transportation. And also we talk about a design method like better analytics and modeling method, the scalability of the cyber physical system, and also how do we verify, you know, the system is useful. That's the research area. So if you are interested in doing research in CPS or finding a job, like an R&D job, this one shows a really good direction map. Okay, just want to share you more about this IoT thing, something about definition. The first IoT machine actually was invented in 1982 at Carnegie Mellon University by 4 exercise challenged while smart students. They just didn't want to go downstairs to check if the machine still had a Coke. So they basically added sensors to the vending machine so they could check the status in the bed in their dorm room, okay? So they spend hours to program in that screen, but they just don't want to go out and check, you know, the status of the machine. But anyway, this is the first IoT machine and it's still on campus of CMU. Just give you some sense. The first web page was created in 1991. So this was like almost 10 years before the first web page. Like I said, by 2020, 50 billion things will be connected. We're talking about cars, we're talking about your lights, AC, phones, of course, pretty much everything can be connected, including yourself. Did you guys see the news like a couple of days ago, Elon Musk actually, the Neuralink thing, they can print the sensors into your brain, right? So think about that. It's possible in the future that, you know, you and me are connected via this CPS, and you do not need to tell me what you're thinking. I know that you are feeling really bored with the classes now, so I can read your mind in the future. And talking about the applications of that, you know, from 1982 to 2018, we have observed about a 31% increase every year, the market value in smart home, smart transportation, smart manufacturing, smart healthcare. You know, we're talking about adding sensors to the patients and also at home nursing. And so the doctors can access your data in real time and everything's connected, right? Smart agriculture, how about smart construction, all right? Will that be the future? Will that be possible? So what is the Internet of Things? I'm going to send this, actually I shared the course note with you. I don't want to go over all the details, you know, it's fairly boring, but this is the formula you want to remember. Sensing is not intelligence. Sensing plus connection is intelligence. Do you guys know how many brain cells we have? Average. Of course, somebody has more brain cells, somebody has less. But on average, how many brain cells we have? 100 billion brain cells. That's why we are smart. 100 billion brain cells each person. That's the number of stars in the galaxy, okay, in the Milky Way galaxy. That's interesting. So anyway, if you take each brain cell, can I say that the brain cell is smart? No. If I present you with 100 billion brain cells, but there's no connection at all, can I say they're smart? No. They are smart because they are connected. Make sense? You add a sensor to my, let's say, lights, to my computer, to my phone, to my mouse, it's nothing. Until you connect them, until they start to share data, they start to form a huge virtual brain. That's when they start to become smart. That is the key word for what? For Industry 4.0. Everything's about a connection. Make sense? All right. All right. Here's the last part. I really want to have a discussion with you guys because I'm so tired of talking to a silent screen. Automation or augmentation, okay? This is a picture of the old Ford manufacturing factory taken in 1939, all right? This is the picture taken in 2014 at one of the Tesla's facility. What's the difference? Anybody?
Difference of labors and machines.
Yeah, so automation, right? All right, if that is the case, this is what the current construction look like. So what is the future construction look like? Of course, automation and machine, right? Wait a second. Are these all only machine? What's this? What's this? What's this? What are these things? They're human beings, right? In fact, if you check the news, Elon Musk actually said that last year or 2018, he was considering to downsize the use of robots. Why? I don't know if I have the news here. Anyway, there's news. We still need a lot of human involvement in current modern production system. Human intelligence still not replaceable with machine. Like what you see here, machines doing repetitive works, but all the guys, what do you guys know what they are doing? They are the boss. They are telling the machine what to do. Who is still playing the most important job here? Who is still making all the decisions? Who is still playing the intelligent part of the game? Us, not the machine. Automation doesn't happen overnight. This figure shows autonomous vehicles. By the end of the 2050, we would have only about 50% autonomous vehicles. So what does that mean, guys? That means for a really long period of time, there will be human drivers and autonomous vehicles mixing together. That will change our behavior a lot. Actually, in Europe, they already observed the human bully behavior. Like when you know the other car is an autonomous vehicle, what will you do? People tend to cut the way. They want to see how the autonomous vehicle is reacting to that. Unfortunately, we don't quite understand the implication of that. And that's why when automation doesn't happen overnight, we need to understand human automation, when they come together, what the problems are. Make sense? This is a very interesting report by McKinsey in 2017, Technology Jobs and the Future of Work. They surveyed more than 2,000 jobs in 46 countries, and they found only 5% of jobs can be totally automated. What does that mean? 95% job will still be human-machine collaboration. The grand challenge to the future industry is human-technology interaction. And this is NSF 10 big idea. The number 2 big idea is the future work and the human technology frontier. Understanding how constantly evolving technologies are actively shaping the lives of workers and how people in turn can shape those technologies, especially in the world of work. And this is the UK Government Construction 2025 report. And they say we need 3 strategies, to advance construction industry. Number 1 is smart construction and digital design. We are moving quickly towards a digital economy with profound implications for our built environment digital technologies are central to this end. Indeed, transition to a digital economy will drive fundamental changes in our everyday lives. All right, so here is the ongoing debate: automation or augmentation. We have seen two opinions. One opinion shows that we need to totally replace human beings in works, including construction. So that's why we are talking about autonomous vehicles, smart communication system, smart power grids, smart transportation, that everything is smart and automated. Or another group of people say, no, we need to think about how technology can augment us. That's why we say augmented perception, language understanding. Think about the natural language processing is about machine understand us, but still us making decisions and giving orders, right? And also aided decision making. Now the discussion point I want you guys to have now is, which side do you believe? I'm not saying that we should think about human augmentation. No, I'm asking your opinion. From today, in about 30 years, let's say, what would the future look like, including construction? Automation or augmentation? Anybody?
Augmentation, I think.
Is that?
Augmentation, I guess.
Okay, can you explain?
I don't know. Like,
That's a
it's
good
not likely. Yeah.
I would say automation, because there's a lot of ethical dilemmas with that around augmenting humans with machines and stuff.
So if it's automation, let me ask you a quick question. How about unemployment? And like, if automation is going to replace human beings in certain tasks, for example, truck drivers, like where do we place those people?
I don't know. I don't.
So think about that. About 400 years ago, when we started to have the first industrial revolution, when steam engine can boost the productivity by 10 times, people had the same concern, like, oh, we're going to experience significant unemployment rate, and we have no place to place those people. But what happened? It never happened. We actually created new jobs, right? Like, for example, maintaining the steam engine, and also engineers. We started to have a whole lot of engineers that focus on designing new machine. That's actually a new job that never happened before. So once again, this is my personal opinion. When I saw the news and articles talking about, oh, automation is going to take over the jobs from American, my first impression is no. New technology, including automation, will only create new jobs for American. We will experience some jobs, some tasks that we have never experienced before. For example, software engineers who focus only on understanding machine language, for example. So to me, it is not a concern. Okay. So who else?
It could be a mix of both.
Mix of both.
Like, for instance, the embodied intelligence, like in construction, where we carry out operations such as excavation and other part where we need to dump dirt and all, we can use self-driving cars and smart communications. While in the part where we are carrying out the building operations, like laying out steel and everything, we can use augmented humans. Could that be possible?
That's possible. Of course, we are not talking about a 100% automation or 100% augmentation. But I guess I also wanted to know your opinion in which will become the mainstream. By mainstream, I mean, in about 30 years, everybody's talking about what? For example, I give you a quick example. Two robotic technologies, one is exoskeleton, one is the humanoid robot. You know the difference, right? The purpose is quite different. Humanoid robot is to replace humans, but exoskeleton is to augment humans. Now the question is, in about 30 years, which one will become more popular? Do you have an answer? Do you have an opinion?
It should be exoskeleton.
Why would you think that?
Let's suppose you're carrying out some heavy sort of operations, for instance. So you can, with the help of exoskeleton, you can do it rather than replacing human. That could be an easy way out, I feel.
So what is the part in human that it cannot be replaced? Why don't we just, if human is doing this labor-intensive work, why don't we just totally 100% replace that?
Intelligent.
There is restriction.
Looking out for the risk in other parts, like carrying the judgment part.
The judgment part, decision-making part, right?
Yeah.
So how about artificial intelligence? You know, we know AI can do a lot of amazing things today. Why don't we add more AI component to robots? Why don't we let robot make decisions for us?
It will be hard to control it.
It's very hard to control that. That's a very interesting angle, right? And it's kind of like what in, oh, there's a term called a singularity. You guys have heard about that? Let me show you. Do you kind of see the word here? And do you know when the singularity will come? This IC shows that singularity will come here. We have 10 more years, guys. So robot will take over human society in about 10 years. Yeah, that's actually a really interesting angle. My personal opinion about AI, so this is, once again, my personal opinion is, they're not omnipotent. So I don't think they can do everything. AI can learn from humans, but when AI faces new situation, they don't have our ability to understand new things. You got my point? So AI fundamentally is just a mathematical model. It's modeling our knowledge. It's modeling how we think. But there's still something cannot be mathematically modeled today, which is how human brain understands and reacts to new things, new experience. We still don't quite understand why human brain can do it. Because we don't know how to mathematically model that, we cannot transfer that to machine learning. Make sense? So that's why even the smartest of AI cannot handle new things. That's probably why humans cannot be 100% replaced by robots. But once again, this is my personal opinion. And here comes an interesting story. Why our brain has that ability to deal with new things. Think about a machine with 100 billion neurons and 20, 30 times of that connections. That is a very complex network. And we don't know what magic that network is playing. That's our human brain. All right. Anything else about automation over augmentation?
I think because we human have our people feelings and the objective feelings, but the AI only they follow our orders and they have their feelings is like subjective feelings.
You know, this is also a very interesting theory. Making mistakes is part of what makes us human. You know, like you said, we are not perfect, and we are always often emotional, and we are often make mistakes. But making mistakes is probably why we outperform machine in a lot of things. And this is about something called search space. I don't know if I can find that paper, penis. Let me see. Here it is. Do you guys know the Journal of Peanuts? This is actually the third, number 3 journal after Science and Nature. It's the Proceedings of the National Academy of Science of the United States. Let me show you this interesting paper here. Can I read the title? What do I mean? They basically hired 20 freshmen from law school and gave them a lot of lawsuits and asked them to predict the result. And they compared the result against 20, 30-year experienced lawyers. Guess who win? Anybody tell me who win?
Experienced lawyers.
No, the students, the freshmen. That's why a group of novices often outperform a group of experts. Let me find a book. This is a book written by a famous journalism called The Wisdom of Crowds. And basically, it lists all the cases that showing the same number of novice, no experienced guys, they can often outperform experts. And this paper mathematically proved why that is true. I really love this paper. So basically say, think about this thing. I will try to interpret this paper. Designing an airplane, okay? And we can often parameterize the design of something. Like for example, the angle of some curve and also the length and also the density of some material. So imagine each parameter is a dimension in the space. So now if you have really a lot of parameters to change, you have a really high dimensional space. And you get one point, that's a design. Make sense? Think about that. If you have 3 parameters, one is the density, one is the curvature, and one is the length, then selecting one combination of density, curvature, and the length, that's 1 point in the high dimensional space. Make sense? Now, in order to find the best solution, it's kind of like moving in this high dimensional space, find the best point. Make sense? Experts are trained in the same way. So they often search in the same direction. Make sense? 20 experts do not make much difference than 1 expert. They are thinking pretty much in a similar way. But think about 20 regular people, 20 novices. They don't care. They don't care what the rule is. They always break the boundary. They observe their behavior. It's kind of like you have 20 points here. That's regular people. That's novice. From the very beginning, they just randomly move in that space. Make sense? And all the 20 experts, they are tend to moving to the same direction. Now think about, I turn off the lights in this room. I shut down my window and I have a ring. I lost it somewhere in the room. The job is to find the ring. Okay? And if you have 20 regular people and they are randomly searching the room, or we have 20 people, they just line up, search the same room. Which team is more effective? 20 people randomly search different directions, or 20 people search the same direction. Which team is more effective? Of course, randomly. Yeah, and then communication is also important, right? So when somebody see, oh, I see some flashing there, guys, come here. That will basically converge to the best solution. This is why committing mistakes are so important. Make sense? You know, committing mistakes is kind of like a break the rules, break the boundary, and do some crazy things. But maybe because doing the crazy things, we discover a brand new way to solve the long-lasting problem. And I guess, I know the country is experiencing a lot of things going on. One thing is about diversity and inclusive. I don't think that's a political thing. I think this is a mathematical thing. Why difference is important, why diversity is important. Hold on a second. This is another book called The Difference. This one basically shows the value of being different. This one shows the error of having some bad performers or somebody is so different than you inside your team. These two books deliver the same thing. This kind of team is often more effective than a team with the same type of people. Why? Because we are different. We must appreciate that. Because we are different, we bring different experience, we bring different mentality, we bring different methods to the team, and who knows, maybe something we can be considered as stupid action would lead us to a much better solution. That's the mathematical foundation of inclusive. That's the mathematical foundation of diversity. Okay, so I think I talk about something probably not relevant, but I think that's the most irreplaceable part of human intelligence. That's why I'm a deep believer of augmentation, not automation. I believe deep in my heart, something that is making me weak compared to machine, something that make me stupid compared to machine, would be the game changer in the future. So that's my personal belief. Once again, it's my personal opinion, and I welcome, your comments and your opinion. All right. Okay, so that would be our first week. I hope our first week would be smooth. And before everybody leave, please go sign up for a team. Let me check what's going on now. Yeah, we do see some teams here already. And also, we do need a volunteer for the second week. Let me check. Unfortunately, no. You guys are smart. So anyway, I guess then we only got 8 people this year. Okay, so I guess second week, third week, there's no paper reading. All right, so see you guys next week. I hope you enjoy your semester, and I hope you learn something from this online experience. And if you have any problem, any questions about class, send me an email. I'm usually very responsive, you know that. And also you can use the online discussion and to exchange your thoughts. All right, guys, see you next week. Bye-bye. Stop recording. Where's that?